We are live. Awesome. Here we go. Another amazing workshop coming up for you guys. I'm super excited. You might notice there's a little black square in the small of my screen there, but that's just because Kate is in. She's off of a hotspot right now. She's in the Middle East doing some great work. So to keep our stable internet, we're just gonna go sight unseen, but trust that she's there. She's a real human being out doing some amazing work. But we're going to jump into the workshop in just a second. But before I do so, I want to mention a couple things for all of the folks that are already in the room. So if you take a little look down at the bottom of the screen, you will see an ask a question spot there. Throughout the workshop, you can feel free to ask questions using that button. And then if you see a question that's already there that you like, you can upvote that question so that it gets to the top, and I will shout them out for you during the workshop. Also, just beside that, you're going to see a polls button. We have a couple polls out there for you to answer. We want to get to know a little bit of information about who's hanging out with us. Yeah, I think that is about it for now. So to give you an idea of who's speaking today, Kate Stapleton has a degree in strategic management and entrepreneurship, as well as a degree in English literature and professional writing. She has a background in cybersecurity and has been developing on the Ethereum blockchain for the past 3 years. She also founded her Concordia University Blockchain Club and is the community organizer for the Blockchain Developers United group. So an amazing, eclectic background there. And so I'd like you all to give a nice electronic hand clap for our next speaker today, Kate Stapleton. Welcome, Kate. Are you there?
I am, yes. Thank you for having me. And I promise I'm not a bot. I'm a real person.
Yes.
There's no webcam on this computer, unfortunately. But I am a real person. I'm here. I'm excited to be here. And yeah, I'm excited.
Super. So I want to ask you a couple of questions before we get into your talk today. I know you got some great material for us, but in just reading your bio, I found like it's such a eclectic background, like strategic management, entrepreneurship, and then writing. So I want to know, like, how did you make the jump into crypto from all of that background?
Yeah, eclectic is a nice word. I'm going to use that word from now on. Um, so the degree in business was kind of just, you graduate high school and pick business because it was safe. But I've always worked in cybersecurity. That's always been a passion. It's always been, I've always done contract work. And in doing so, I was very involved in different, hacker groups, and I was on the cypherpunk mailing list. And when we got the email about, Bitcoin, it was very exciting. And it's kind of this cool new thing because it seemed to have finally solved all the issues that DigiCash and eGold and all the failed attempts from the 90s and early 2000s couldn't tackle. And so I kind of got involved back then. And, as a hobbyist, I was mining for fun. I wasn't contributing to the core protocols at all. But then when Ethereum came around, I really started to realize the what's the word I'm looking for? The impact it could have, right?
Right.
The possibilities of this network, of this decentralized network that anyone could contribute to, anyone could build on. From being in cybersecurity, that's the word. Being in cybersecurity, I love an open source project. I love anything open source. And so it really struck me as a fantastic opportunity to start building decentralized applications and contributing to this really, really cool protocol and building on this really cool network. So that's kind of how I got started. And English literature was a hobby. I figured I used one side of my brain so much that I should, maybe try and exercise the other side as well. And I've always loved to read. So it was more of a hobby and a distraction from just working all the time.
That's amazing. That's super cool. I love hearing that kind of transition. So you've been around. You're an OG, we could say. Like you've been around through the cypherpunk movement. So what year did you actually like join in the blockchain?
I started mining kind of right away, back when you
Wow,
could just, mine on good old CPU and have it going in the background with your laptop.
that's
So I've been
awesome.
at it for a while, but like I said, I wasn't a core. I didn't contribute to any of the core protocols. It was just kind of fun.
Hmm.
And then, with, like I said, with Ethereum, then I realized really the potential, and got really involved in it at that point in terms of developing and actually contributing to the ecosystem.
That's amazing. Well, it's great to have you here, and I think we're gonna kick it off in earnest now. I think a bunch of folks have trickled in, and so for those of you that joined a little bit afterwards, Kate is going to be speaking today for you, and she has a degree in strategic management and entrepreneurship, as well as English literature and professional writing. She has a background in cybersecurity and has been developing on Ethereum for the past 3 years. And she's also the community manager, community organizer for Blockchain Developers United. So again, welcome, Kate Stapleton, and thank you so much for being here, Kate.
I'm excited to be here. Like I said, really excited for the questions and to interact with everyone, and to talk about blockchain technology and proof of work and proof of stake. So should I share my screen and kick it off?
Yeah, go ahead and share your screen. Again, for the folks that are in the room, go ahead and use the Ask a Question button down below, as well as the Answer Our Polls there. Let's see what kind of answers we got, actually. So I asked, which consensus method do you think is better, proof of work or proof of stake? And we've got a resounding 80% saying proof of stake. We have got 0% for other. So it's one or the other, proof of work or proof of stake. Those are the only two options we're considering so far. We'll take a look at the end if anything changes, anything gets added there. What else do we have? Do you think the shift to proof of stake is going to be successful on Ethereum? And we definitely want you guys to discuss this out in the chat. But let's see, we got 33% saying yes, can't wait to stake my ETH, and we're winning, we're edging out with a undecided. We're waiting to see if ETH2 ever drops. So we also let's see what Eleanor is saying in the chat. Proof of work and proof of stake offer different incentives, both valid in my opinion. That's very true. So let's see what Kate has to say about it. And by all means, guys, keep the chat going on the side there, and ask your questions, and I'll shout them out while Kate's going. And so for now, I'm going to shut up and let Kate take over. So the stage is yours, Kate.
All right, awesome. I will share my screen and get started. All right. Perfect. Cool. All right. Can everyone see? Everyone can see the screen?
Yep, I see you. Yep, and here you're good.
Perfect. All right. So, how does blockchain work? What is proof of work versus proof of stake? So I'm going to kind of start a little bit broad, just to make sure that everyone who is sure about some aspects but unsure about other aspects is completely onboarded. And then we're going to kind of get more into the technical aspects, and then end off with proof of work versus proof of stake. So as I said, we're going to do the technical overview first, right? So cover decentralized databases. Then we're going to get into the block breakdown. So what are hashes? What's consensus? Then we're going to get into the proof of work. We're going to discuss incentive. We're going to then transition to peer-to-peer ledgers and discuss private key encryption. We're going to end off with proof of stake. And at the very end, kind of compare the two. So do a real comparison between proof of work and proof of stake. So let's start. So what is blockchain technology, right? Blockchain, very broad. It's a type of technology and not one single application, right? So think the internet versus email, where blockchain is the internet and Bitcoin is email. And cryptocurrencies, they're just one application that runs on top of blockchain technology. And so what does blockchain do? Well, it creates an incorruptible digital ledger of transactions that can be programmed and track not only financial transactions, right, which is what we hear about the most, but anything of value, including information, files, etc. And so for this talk, right, for the sake of clarity, so we're all on the same page, I'll be discussing financial transactions based on the Bitcoin blockchain. So that's what I'll be referring to throughout. So here is kind of like the most basic breakdown of blockchain technology and how it works, right? So A wants to send money to B. The transaction is represented online as a block. The block's broadcast to every party in the network. The network approves the transaction, and then the block is added to the existing blockchain in a transparent and unalterable way. And finally, the transaction is complete. So this is literally kind of the most simple breakdown that we can do. So now we're going to kind of get more into the nitty-gritty of it. So a blockchain uses what you're going to hear me refer to this a lot through the talk, a distributed database to source the information for this distributed ledger, right? And this means that all the information on the blockchain is part of a shared and constantly audited, right? So it's always being checked community database that's not stored in one single location or by any central authority, making it completely decentralized. And this means that there are public and verifiable records. So anyone can check at any time for every single transaction. And this means also that there's no central point of failure for anyone to attack or alter. So like robbing a bank or altering bank records, it's not possible on the blockchain. So as you can see, a blockchain, it's a collection of records that a crowd oversees and maintains, rather than the traditional way of relying on a single entity, like a bank, to host all of the data on a single or proprietary server, right? So we have the centralized database on the left, which is what traditional banking relies on, and then you have the distributed database on the right, which is what the blockchain is based off of. So a blockchain, it's hosted by millions of computers called nodes. So when you hear me refer to nodes throughout the talk, I mean computers simultaneously. And this means that all the information is shared across the public blockchain. So all these computers get a copy, and it's accessible to anyone at any time. And every node acts as an administrator for their particular blockchain and is part of the network voluntarily. So people choose to be nodes on the network. In the blockchain, it exists in a constant state of consensus between these nodes. And this means that the network automatically checks in with itself during a set amount of time to check and then recheck all the transactions. And this is what makes it a self-auditing ecosystem of connected nodes. So it's always checking and rechecking to make sure that all the transactions in the blockchain are still valid. And so every transaction that occurs within a set amount of time on the network is lumped together. And in the Bitcoin blockchain, it's about 10 minutes. It's then reconciled, right? So it's then accepted as legitimate, or it's rejected as fraudulent by the network as a whole. And these groups of approved transactions are called blocks. So this is where you get the block portion of the blockchain. So what exactly does a block contain? What's we hear about blocks all the time, but we're going to kind of pull the hood up and see what's going on. So each block contains its unique data, so its unique hash and the previous block's hash. And the data stored inside the block depends on the type of blockchain. So different blockchains will have different data stored in the blocks. But like I said, for this example, we're using Bitcoin. So let's take a look at what is in a block. So here, I'm just on the blockchain.com block explorer. So here we have block 623,063. And again, this is, you don't need to log in to see this. This is public information. It's just blockchain.com. And then you click on the Explorer. So what's going on with this block? So we have the hash right here, which I'm going to get into in a little bit, what hashes are. We have the number of confirmations. We have the height. We also have the miner. So this, again, we're going to get into mining in a bit, but this block was mined by Antpool. We have the number of transactions in the block, so 597. And then we have the difficulty. And so difficulty is how difficult it is to calculate the hash, which again, we're going to get into. But essentially, this is how difficult it was to calculate the hash of this block. And it's measured in, sorry, I just cut it there, total hash rate. So this is the total hash rate right here. So yeah, you can kind of go through and see anything you'd want about the block, the weight, the knots, these are very, very technical breakdowns, but if you hover your cursor over, it'll kind of give you a basic description of what they are. And then you can also get into block transactions, right? So here's the hash here. And this wallet here, which if you click, you can see all the information, all the past transactions. sent this amount of, here we go, sent this amount of, you can also switch back to Bitcoin, this amount of Bitcoin to these addresses. So you can really kind of do a deep dive and check out anything you'd want. And this is what I mean when it's a part of a public ledger, right? So anything you want to know about the block, about the hash, about the different addresses the transactions are being sent to and from, it's all publicly available. And like I said, you don't need to sign in. Anyone can check this out. So, all right. So as you can see, right, the blocks contain the information of more than one transaction. So what this means, this is what I mean when I say that a blockchain represents a public ledger, right? Like I showed you, anyone can access and view every transaction on the Bitcoin blockchain at any time. And each block, right, that we just broke down, it represents a transactional record, but it's the chain component that links them together. And blocks are created by first being confirmed by the distributed network of nodes and then permanently linked together with the previous entry in the chain with a hash function. So what is a hash, right? We have kind of the basic breakdown of what a block contains, but then how are they linked together? Where does the chain component come in? This is where hashing comes in. So hashes they're a mathematical function that converts an input of letters and numbers into an encrypted, right, which is very secure and almost impossible to crack, output. So before, it would be legible to you and I, and after, it would be illegible. And a hash is created using an algorithm, right? Thus a hashing algorithm is used to hash plain text into hash text. And a hash, it's like a fingerprint. It identifies the block and all of its contents and is always unique.
Can I ask a quick question?
Yeah.
You mentioned that the cryptography is like almost impossible to break. Can you talk a little bit about like what makes it almost, or like what it would take to crack it?
I mean, I use almost just because, absolute terms in cryptography and this sort of thing. A lot of people say impossible, but I like to use almost impossible. It would be almost impossible due to the computing power and the number of years that it would take to crack these algorithms, but it wouldn't be impossible if you had a few hundred or a few 100,000 years to do.
Right. Yeah.
Or,
I think that's always important. No, yeah, I think that's always important to mention. Like in cryptography, we do probabilities, right? So it's more probable that an asteroid would hit the Earth than it would be that we would crack the encryption here, right?
Yeah, exactly. And I also leave kind of that room for, for uncertainty, like with quantum computing. We don't know what that's going to look like. We don't know how that's going to change the landscape. So I don't like to speak in complete absolutes, so that's why I say almost impossible.
Perfect. Thanks.
Yeah. So so once a block is created, it's need to install updates on this computer. So once a block is created, its hash is constantly being verified, right? So like I said before, the blockchain network, it exists in this constant state of consensus. So changing something inside the block, like trying to tamper with already approved transaction information, like how much Bitcoin somebody sent you, this will cause the hash to change. You're changing the unique fingerprint of that block. And the first block in any blockchain is special, as it can't point to any previous blocks, right, since it's the first. And thus it's called the genesis block. And so, like I said, if the fingerprint of the block or the hash changes, it's no longer the same block. And since each block contains the hash of the previous one, part of what makes the blockchain so secure is that by changing the hash of one, it affects all the remaining blocks in the chain and they become corrupt. So if an attacker were trying to tamper, say I'm an attacker, I want to tamper with the second block on this 3-block chain here. It would cause the hash of that block to change, making the third and all of the following blocks encrypted. So this is what it would look like, right? it's supposed to be PP4, and now it's been altered, and we've caused a fraudulent.
Oh no, it looks like we might have lost Kate there for a second. We're gonna hang tight. I think she should jump back on. But in the meantime, here I am to hang out with you. Let's take a look at what our polls are saying. All right, so proof of stake is still winning the battle, but it's not there's no other options in terms of what people are answering. So we have proof of work as an option, proof of stake as an option, but nobody's choosing another option. So that's super interesting. Let's see here. Give me one sec. I'm going to try and connect with Kate. Okay, I think Kate's about to come back in, but let's take a look here at our other poll question. Do you think the shift to proof of stake is going to be successful on Ethereum? 28% of you guys say yes, they can't wait to stake their ETH. We got a 12.5% nope, gonna fail. Just don't have any faith in Ethereum whatsoever. And a resounding 62% of you guys are saying that you're just waiting. You're gonna see if Ethereum 2 ever arrives, and you'll play it by ear from there. I think that's reasonable. Kate, can you hear us? Are you there? I see her. I see her black square.
Yeah, I can hear you guys. Can you hear me?
I can hear you. Welcome back. Oh, yeah.
There we go. Okay. Can everyone hear me?
Yeah, we can hear you. So yeah, if you got your slides right where they were, you can pop them back up. Perfect. And we can continue.
Okay, sorry about that. This is the joys of being very remote. Yeah. Okay, so perfect. Can everyone see the screen?
I don't see your screen.
Okay, let me try this again. Sorry. The joys of technology. All right, are we good?
Right. Yep. There we go. We're right back to where we were.
Okay, so I think I dropped off at just explaining how hashes alone, they're not enough to prevent tampering. Is that correct?
Yep. And you were showing that, if you changed it, then the PP4 doesn't match with 9BZ.
Perfect. All right. So yeah, as I said, hashes alone, like they're not enough to prevent tampering, right? You can't just have one mechanism that is wholly that you rely on completely for security. So to protect the blockchain and all the transactions on it even further, it uses something called proof of work. So for a block to be successfully added to the chain, a really complex puzzle has to be solved. And this is called a cryptographic puzzle. And the computer that solves that puzzle first shares the solution to all the other computers on the network, or the nodes. And this is called the proof of work. And mining is what creates incentive to submit these valid blocks, since it takes a huge amount of computing power to do. And so miners, right, which are machines created with the sole purpose of solving these transactions. This is a pretty popular one, the ant miner. This is what it looks like. Of solving these puzzles, not these transactions. They verify and approve transactions, and they're awarded Bitcoin or whichever cryptocurrency they're mining, but we're going to kind of stick to Bitcoin for the beginning of this in terms of clarity. So they're rewarded with Bitcoin for lending their computing power to the network and successfully adding a block, so mining a block and adding it to the chain. So every 10 minutes or so, all of the valid transactions that have been broadcast to the network are added into a block and hashed, right? So all the information is compressed into a string of numbers and letters, as we discussed before. And then the miners on the network compete to solve the hash, which is a difficult mathematical problem based on the cryptographic hash algorithm that I discussed before. So there's a lot of moving parts, but they're all going to fit together, hopefully, by the end of this. And the solution, as we just briefly discussed, is called the proof of work, right? The solution proves that a miner spent the time and the resources necessary to solve the equation. And the first miner to solve this problem then broadcasts the result to the rest of the network so that they can confirm, the network can come together and confirm that the solution is valid. So when a block is solved, the transactions contained are considered confirmed and the block is added to the chain. And the combination of these pretty complex mathematical equations, as well as the distributed verifications by the nodes on the network, creates trust in every block on the chain. So we're adding layers of trust now. We're adding layers of security to the blockchain to make it safe for users. And so this means that trust can be decentralized securely, right? You don't need to rely on a single trusted third party like you would a bank traditionally. Instead, you can rely on the distributed nodes on the blockchain network. And so proof of work, what it does also is it slows down the creation of new blocks. And in Bitcoin's case, as I'm sure a lot of you are aware, currently it takes about 8 minutes to calculate the required proof of work and add a new block to the chain. So here's a look kind of in real time at another block explorer. This is BitInfo charts.
As you're switching,
we've got all the different, popular.
Sorry, I was going to jump in with a quick. No, you're good. You're good. I was going to jump in with a quick question. I remember you mentioned
Sure.
the difficulty earlier. So how does that play into the 8 minutes that it takes to create a block?
So difficulty, what it does is it, like I said, it's how difficult it is to calculate the hash, but like I said, which is measured by the total hash rate. And so high difficulty means that it takes more computing power to mine a block. And this kind of keeps everything constant, right? So difficulty is adjusted every 2016 blocks, so every 2 weeks or so that the average time between blocks is 10 minutes. So it's kind of a regulating force on the blockchain to make sure that about every 10 minutes, a new block is added so that you don't have to wait 10 hours for your block to be added. So that's, it's not fixed. It adjusts depending on how many miners and users are on the network.
That's amazing.
All right, so here, right, we have Bitcoin, Ethereum, Ripple, Bitcoin Cash. And so this is another cool thing about having a completely public ledger is that you've got, the total Bitcoin. You have the price. This is US dollars. I'm based in Canada, so it's a little bit more. Then you can really get into, so there have been 365,391 transactions in the last 24 hours. About 15,000 transactions per hour on average. This is how much Bitcoin has been sent in the last 24 hours. The average Bitcoin sent per hour, the average value, the median transaction value. And so, so the block time is currently sitting at about 9 minutes and 36 seconds and about 6 blocks on average per hour with 149 blocks added in the last 24 hours. And here's the difficulty that we were talking about, right? There's the hash rate. And so you can really get into kind of anything you can imagine with these block explorers. And not only for Bitcoin, but as you can see, for all the other cryptocurrencies that you're curious about as well. So let's hop back into this. So basically, there we go. All right. So basically what all of this does is it makes tampering with blocks really difficult, right? Since, like I said, you tamper with one block, it means you forced the recalculation of the proof of work for all of the following blocks in the chain. So by by changing that one fingerprint, you forced all the following blocks to have their proof of work recalculated. So security on the blockchain, it comes from this combination of hashing and the proof of work mechanism. So far, this is the security that we've covered. And now another layer of security that we're going to talk about is peer-to-peer, right? So it comes from using a peer-to-peer open network where everyone is allowed to join. So when somebody joins the network, right, if I want to join the network right now, my node would get a full copy of all the transactions on that particular blockchain. So if I want to participate in the Bitcoin blockchain, my node gets a full copy of every transaction ever broadcast onto the Bitcoin blockchain. And so the node, right, my node or anyone's node who joins, would use this information to verify that everything is still in order and that all the transactions are still correct. And as I mentioned, right, the blockchain exists in this constant state of consensus since it's constantly verifying the hashes and the proof of work statements. So basically, to kind of sum up what we've covered so far, here's how traditional centralized ledgers work, right? You have Bill who wants to send money to Justin. You have to go through this centralized ledger. It's public knowledge, transact directly with each other, right? So Mark would have to go through his bank to transfer money to Jenny, and then Jenny would have to go through her bank. So that's kind of the antiquated.
Hello again. Looks like the lovely hotspot that Kate's using is giving us a little bit of a trouble. But you know, we're gonna hang out until she jumps back because this talk is amazing. I'm learning a ton. What do you guys think so far? Let me know in the chat. Also, if you have any questions, make sure you drop them in the Ask a Question box down below. Let's take a look at these polls. I saw a few new folks come in. So please, if you haven't answered our poll already, head over to our polls and let us know what you think. Still, proof of stake is kicking butt. And a lot of folks are just waiting to see how Ethereum 2.0 pans out before they get involved.
I think I'm back.
Kate is back.
Okay,
awesome.
Sorry, guys.
No worries. Take over whenever you're ready.
All right. Okay. So, as I was saying before my hotspot rudely interrupted us, here is how the blockchain's peer-to-peer ledger works. Right, so Bill can now transact directly with Jenny. He can transfer, coins, cryptocurrency funds, anything right to her, and there's no middleman, right? So there's no central ledger in the middle controlling everything. It's all part of a public ledger that anyone can access and participate in. So, okay. There we go. So the last piece of the security puzzle that keeps the blockchain secure, it's really strong encryption. And this is in the form of public-private key encryption. And this ensures that users on the network can trust each other. And it's also what allows users to transact directly with each other without the need for a trusted intermediary like a bank, right? So that's what allows us to go from this to this. And encryption, it's the process of taking information, like I said, and scrambling it so that only certain people with permission can view it. And there's two kinds of encryption. There's symmetric and asymmetric, but blockchain uses asymmetric. So that's what we're going to cover. So some wonderful drawing here. You're welcome. So asymmetric public-private key encryption sounds very intimidating. We're going to break it down. It's very similar to a mailbox, right? The public address is like your PO box address. Anyone can see it and send mail there, but only your key opens the mailbox. So only you can read the letters that are inside. So here with this wonderfully illustrated example. To transact with each other, Alice and Bob, good old Alice and Bob, if anyone's ever done anything with cryptography, you know Alice and Bob. To transact with each other, they both have to generate a key pair on their computers, and this creates their public and their private keys, hence public-private key encryption. And one of the most popular and secure ways to do this is using the RSA algorithm to generate public and private keys, and these keys are mathematically linked to each other. And what the public keys do is they encrypt data, and the associated private key is the only key that can decrypt this data. And even though the two keys are linked, as I mentioned, one cannot be derived from the other. And so this means that even if you know someone's public key, you can't figure out their private key. And so going back to the mailbox analogy here, the owner of the PO box is the only one with the private key, right? So Bob and Alice, they generate their public key pairs, and then they exchange addresses or public keys. And then Alice encrypts her message with Bob's public key and then sends it back to Bob, who uses his private key to unlock the document and view it, right? And so even if Eve here in the middle is snooping on the network, she can't figure out what text is going back and forth. She can't decrypt the messages. And so asymmetric encryption, it ensures that only Bob can decrypt the message and read it, so no one else can. So in Bitcoin, asymmetric encryption, it ensures that only the owner of a Bitcoin or cryptocurrency wallet can withdraw and transfer funds to and from it. So these messages here are in fact transactions, right? So these messages that are being sent back and forth to these, using this mailbox analogy, in terms of Bitcoin, they're transactions. And so cryptocurrency wallets, they're what generate your public and your private key. And they also provide the addresses to send and receive cryptocurrency. So your public key, that's where people can send coins to, and your private key is what decrypts the funds and what allows you to access them, and only you to access them. So basically, public key encryption used in digital wallets, right, in a blockchain wallet, it would look like this. So two people, Alice and Bob, they want to complete a Bitcoin transaction. Each of them holds a private and a public key, which creates a secure digital identity, because your public key and your private key equals a digital signature, which mathematically verifies that it's you. So the process begins with A, or Alice, taking their private key and making an announcement to the Bitcoin software that they're sending a specific amount and attaching it to B, or Bob's public key, resulting in a transaction record. Then this record is added to a block that contains the transaction's digital signature, as we discussed, a timestamp, and other relevant information, which we've gone over, and again, which varies from blockchain to blockchain, which is then broadcast to all the nodes or the computers in the network in mined. And then once confirmed, Bob uses his private key to unlock the transaction and receive the funds. So to end kind of this portion of the lesson, it's a combination of these three key technologies: a peer-to-peer open and decentralized network, unique protocols like Bitcoin's proof of work and mining, and public-private key encryption that powers a blockchain, secures it, and allows it to be completely decentralized, right? So it's all of these individual factors that, when combined, as Bitcoin has done, allows us to transact with each other in a completely decentralized manner and in a trustless manner that also ensures trust and security. So that is proof of work, which is kind of what, the most widely used protocol. And now that we have this understanding of proof of work, right, that's used in the Bitcoin blockchain, I'm going to cover proof of stake. And just so there's no confusion, proof of work is used by the Bitcoin blockchain, as well as the Ethereum blockchain and many others. And proof of stake is a different consensus protocol proposed by Ethereum developers. So it's an Ethereum-based protocol. And they both have the goal of reaching consensus on the blockchain, but they take pretty different approaches. So we're going to cover those now. And the proof of stake consensus algorithm, it's not new. It was actually introduced in 2011. So what is a consensus algorithm, as I just mentioned? Well, it's pretty simple. Well, there's a simple explanation. It's not, in and of itself, it's not simple. But it's a mechanism that allows users to coordinate in a distributed setting, right? So it ensures that everyone, all agents in the system can agree on a single truth, even if some agents fail. And so in other words, the system has to be fault tolerant. And this algorithm, this fault tolerant algorithm, it uses a pseudo-random, right? So it's not completely random, which we'll get into, a pseudo-random election process to determine the node which will validate the next block on the chain. And determining factors, again, which we're going to get into, include, among others, the staking age, which again I'll cover. But so there's various determining factors as to who gets to validate the next block on the blockchain with the proof of stake method. So just quickly, speaking of staking, just so that everyone knows, what I'm talking about, and so that we're all on the same page. Oversimplified staking is the alternative to mining, where you stake or lock Ether, for example, on a network in order to be rewarded. So normally you can stake your crypto right from your wallet, or you use an exchange's staking services where all you have to do is hold crypto on the exchange, and they'll take care of the rest. So this proof of stake mechanism, what it does is it seeks to maintain decentralization without the high costs that are associated with proof of work, as well as the really high energy outputs. Because as we know, traditional blockchain Bitcoin mining is not very energy efficient. So in this method, in proof of stake, participants lock their stake, right, their coins, and at set intervals, one node is randomly chosen to validate the next block by the proof of stake protocol. And the probability is usually proportional. So the more you have staked, the more coins you have locked, the higher your chance of being chosen is. So whereas nodes on the proof of work blockchain exert computing power to solve a cryptographic puzzle in the form of a hash, right, as we discussed, with proof of stake, users are chosen to validate blocks based on the amount of staking coins they have. So in proof of work, physical devices, right, like the ASIC miner that I showed you a few slides back, are used. But in the proof of stake method, users invest in the cryptocurrency and as such are chosen based on the amount of coins they stake on the network. And some blockchains reward the forgers, which is what the miners are called, in a secondary token, and some reward in the main token. This also acts as incentive to maintain network security, as their cryptocurrency is online in case of fraud on their part. Basically, staking itself means holding funds in a connected wallet so that users can perform network functions in return for staking rewards. So what is a staking reward? What do I mean when I say that? Well, because this is not as widely used a protocol as proof of work, each blockchain will determine how to calculate the rewards. So right now there's two ways to distribute rewards. So on a block by block basis, or more similar to proof of work, as a fixed percentage. So if the blockchain is using the block by block method, some contributing factors are the length of time a validator has been staking for, the number of coins staked by the validator, and the total number of staked coins on the network. And so there's also a second way of distributing staking rewards, and that's that networks can also use a fixed staking percentage reward. So validators can calculate exactly how much they will be rewarded. And a fixed reward, it can incentivize users to stake on the network since the reward is constant and it's public knowledge. And like I said, they can calculate before what the reward will be. There's also cold staking, which is kind of cool. It refers to staking from a cold wallet, right, which is a wallet that's not connected to the internet, and usually by using a hardware wallet. This is really great for privacy-conscious users since it allows you to stake while keeping all of your funds safely offline. However, obviously, if you stop storing your coins in cold storage, you'll stop receiving rewards. So what's stopping one really wealthy staker from coming onto the network and being algorithmically favored to claim all of the rewards. Well, two common methods kind of deter from this, and these are called randomized block selection and coin age selection. So randomized block selection, it's where the nodes with the lowest hash value and the highest stake are chosen as validators. And the coin age selection is based on how long the coins have been staked for. So it's found by multiplying the number of days the coins by the when a node is chosen to forge a block, their number goes back to 0, and they need to wait to be able to forge another so that large stakeholders can't just take over the whole blockchain. And as I mentioned, each blockchain is different and has different ways of governing staking, right? Most chains require a minimum amount when you're staking, and while the assets are staked, they can't be accessed or sold, so they're locked in. So similar to proof of work, right? When a node is chosen to forge a block, right? As I said, in proof of stake, it's called forging rather than proof of work, where it's called mining. It validates that the transactions inside the block are correct, and then signs the block, adding it to the chain. And this validator is then rewarded with the transaction fees from the transactions in the block. So we discussed security, on using the proof of work method. But how does the proof of stake method keep the network safe from malicious players? Well, it's got to do largely with the financial incentive not to validate or create fraudulent transactions. Because if fraud is detected on the network, the node that's responsible loses part or all of its stake, and also the ability to participate in the forging process in the future. So what's really important is that the stake is higher than the reward, so that if there's fraudulent activity, the forger loses more than they would stand to gain. So basically, when you stake some of your coins via a node, right, which is a server running your coin's blockchain software, to validate this new block, if fraudulent, like if it tries to transfer assets that don't exist, or if your staking node is offline, like I said, some of all of your staked amount or coins will be taken or slashed. However, if it's a legitimate block, and in addition, this reward. The stake deposit requirement, the reward, the slashed amount, all of these vary per chain, like I said. And so it's this system of rewarding and slashing which incentivizes participants to validate only legitimate blocks, right? It kind of forces them to have skin in the game. So 51% attacks, as we know with the Bitcoin blockchain, they can still technically occur. So on the proof of in the proof of stake method, this would mean that a malicious agent owns a majority stake in the network, letting them control the network to approve fraudulent transactions. But to do this on a network using the proof of stake model, you would have to own 51% of the circulating supply. So that is no small feat, nor is it inexpensive. So what are some of the key differences between proof of work and proof of stake, right? As you can see here on the left, the proof of stake model, it's truly decentralized. So there's no hardware tools necessary. You don't need to buy an ASIC miner. There's far less energy that's used than the proof of work method. And so when I say decentralized and centralized, they're all obviously decentralized. But with proof of work mining, proof of work and the mining that that powers it, it's so energy and resource intensive that you end up being grouped into the majority of users join user pools, right? Which kind of re-centralizes the network. And as as I said before, there's specific hardware that you have to buy, as well as the energy consumption that is very, very, very high. So kind of a more general overview of the differences between proof of work and proof of stake. Blocks are mined in a proof of work model, and they're forged in a proof of stake model. The proof of work model mints coins as a reward for the miner, whereas the proof of stake model rewards forgers with transaction fees. As I mentioned, proof of work, it's very, very energy and resource heavy, whereas proof of stake is it's a lot more energy efficient and is greener. In proof of work, you don't need to own any of the cryptocurrency to participate, whereas obviously in proof of stake you do. And you could, as I've mentioned, just now, you could argue that proof of stake is more decentralized since it lessens the need for mining pools that the proof of work model currently uses. Although I do want to note that staking pools do exist, but they're usually on networks where entry is expensive. So yeah, proof of work, the probability of mining a block is dependent on the work done by the miner, whereas with proof of stake, the probability of forging a block is dependent on the amount staked by the user. We're gonna go. There we go. So with proof of work, the miner rewards become smaller when the value of the reward halves every 4 years, right? With the halvening every 4 years, the reward that is given to the miners is halved. Whereas with proof of stake, miner rewards aren't hard-coded and they're blockchain dependent. So mining with proof of work, it tends to become centralized over time, as I've said, through these mining pools. With proof of stake, forging is more decentralized. However, more work needs to be done to build up strong communities to support the proof of stake model and to incentivize users to invest in the cryptocurrency and stake their assets on the chain. So that's it. That's the end of the presentation. Thank you. I guess we'll move into questions. If anyone has questions, let me just stop.
Awesome.
Sharing.
Thank you so much, Kate.
All right. I guess we don't want screen inception like before.
And I'm going to pop back up here. There we go. Okay. Yes, thank you so much, Kate. That was amazing, enlightening. I was just about
Apologies
to ask.
again.
No worries. Yeah, no, it was great. We do have a couple questions down here. Let's take a look what we got. So yeah, one question. You mentioned something about hot storage versus cold storage. Can you go a little bit more into that?
Yeah, so cold storage is offline, right? So this is where you get the ledgers, the Trezors, like this is a physical device that holds your coins that's not connected to the internet, right? So you can have, with hot storage, you can have an exchange wallet where your coins are actually held on the exchange. You can have, like the blockchain wallet, the app that you can download on your phone. So these are hot wallets as they're connected to the internet. And then you have cold wallets, which are, they're not connected to the internet. So this is kind of, they're the most secure way of storing your coins.
Cool. And I guess like to tag on a little bit onto there, I've heard the saying "not your keys, not your coins." How does that play into hot and cold storage, or where you store your coins?
Yeah, so I mean that would tie more into keeping your coins on a software exchange, right? Not your keys, not your crypto. I think that's definitely one factor of security on the blockchain. There's also a lot of other factors as well, right? Like storing your seed phrase, and also just good OPSEC, right? Which is operational security. So trusting the apps that you're using. I personally like to use cold storage just because I'm in full control of my crypto. I'm in full control of my coins. I don't need to rely on, an exchange that might go bust tomorrow and then, they've just made off with your crypto. And I also don't need to worry about having them connected to the internet. And it's really the most secure way of holding your funds.
Awesome. Thank you so much. I think there is a follow-up question to that one. They say, I heard about warm storage. What are those? I guess somewhere in between hot and cold.
Warm storage. I've not really heard too much about warm storage. I guess that would be kind of like a hybrid model between the two.
Yeah, I'm not too
I don't
sure
know,
about
that's
that
a good
either.
question. Whoever asked that, I've never heard of it, but
come find us
I'll
in
look
Discord,
into it.
and we're going to talk about warm storage in Discord. We'll do a little research and get back to you.
Yeah. Yeah.
Okay, so
the after talk is about warm storage.
Yeah. So we got another really good question here. from Victor. Will Bitcoin network remain secure when the block rewards end?
That's the question, right? Is that the less, the majority of, well, the incentive, right, for participating and lending your computing power to the Bitcoin network in the Bitcoin blockchain is the reward that you get, right? The reward for mining a new block and the potential reward for contributing. So when that ends, there is the question of, well, what is that incentive now, right? There's transaction fees that will be rewarded, but you don't have that driving factor, right? That initially kind of created this huge incentive, the tragedy of commons, to based on the tragedy of commons to participate. So it's a really interesting question. I know there's a lot of speculation, a lot of theories as to how it'll affect the blockchain and how it'll affect attacks and participation. But I guess it's one of those things we're just gonna have to wait and see where it goes. But again, that's the cool thing about proof of storage, is that there's no halvening every 4 years, right? It's kind of constant in terms of the rewards, because they're transaction fees that the validators get. So it's a little less volatile,
Right.
than the proof of work model with mining.
And I think that's also like, it's not to kick the can down the road, but that's not going to be our generation's problem, right? Like that's not going to happen for
Exactly.
140 years. Who knows if
Yeah.
like Bitcoin will probably be around, but like how far the industry is going to grow by then. We might have found a different solution. But yeah, I think it's an interesting problem to think about now. But our kids are probably going to be solving that problem. Their kids are probably going to be solving that problem. But yeah, it's a great thought experiment to go through.
Yeah,
Um,
exactly.
let's see, what else do we have here? We got a bunch of questions coming in now. There's one question about the teams in the hackathon that I'm going to answer at the very end. Um, do, do, do. Okay, so you mentioned that you mined BTC in the early days. What are you mining today, if you're mining anything?
I'm not really mining anymore. I've kind of gotten away from that, and I'm really just heavy into like the development. I'm starting to get more into like the DeFi side of it. It is reminding me a little bit of, some of the things that are coming out to musing. It's a little bit like the ICOs of 2017, but there's some really, really cool projects that I'm starting to follow. But in terms of mining, I'm really kind of most focused on just network development and developing on Ethereum and that side of the industry. But I'm looking to get in back more into DeFi and into that part of it as well.
Awesome. That I feel like, just like to riff on that, like DeFi piece, like isn't Bitcoin the original DeFi? Like if we're talking about decentralized and finance, is that not like a piece of the pie? I think DeFi is kind of, it's a bit of a ubiquitous term that we're using to talk about the industry specifically right now. But what are your thoughts on that? Oh, did we lose Kate? We might have lost
Sorry,
her.
you just
Oh,
cut.
oh, you're cutting in and out there, Kate. We
Can you hear
can't
me?
quite hear you. Oh, I think we got you back. Hello?
Oh no.
Okay. While we wait for Kate, there's a couple things that I wanted to
Hello.
mention. Are you there,
Can you hear
Kate?
me?
Yeah, yeah, we can hear you.
Hello.
Can you hear us? Can you hear me? Oh, okay. Yeah. So there's a couple things while we wait for Kate to join back on. Just a reminder, if you're viewing this and you got here somehow without being in our our hackathon, or B, our Discord channel, please join us on our journey. I'm gonna drop the URL to our hackathon. So www.blockhack.ca. Go check out our hackathon page and get some more information, and also sign up. And from there, you'll be taken to our Discord link. So make sure you get into our Discord. And please, if you're wanting to compete in our hackathon, you must be verified on our Discord channel. It is super important. There will be a cutoff, and after that cutoff, if you're not already signed up, then you'll have missed your opportunity. So make sure you follow all those steps there that we send you in the email. All your teammates must be registered individually, and then you can form a team within the hackathon. So if you're planning on hacking with a group of folks, make sure all your team members are signed up, please. All of our workshops that we have planned for the entire hackathon are going to be live streamed as well as recorded. So you can follow us on Crowdcast and view those later on if you've missed them. Are you back, Kate? Are you there?
Yes. Can you hear
Awesome.
me?
I can hear you.
Right. Right. This
Super cool.
hotspot is holding on for dear life.
Yeah. Okay, I won't keep you too much longer. Let's see. Let's take a look at some of these questions here. There's some really good ones. It's hard to pick. I don't know. I don't want to go all day, but okay. Do you use cryptocurrencies for payments? And if so, what are like what's the most efficient that you've been able to use for payments? Because that's a huge piece there.
Yeah, I mean, anywhere where cryptocurrency is accepted, I like to use it. I find that Bitcoin is the most reliable. It's got the most robust protocol. It's kind of the one cryptocurrency that's leading the charge and taking all the hits. The Lightning Network is a really exciting kind of development to be able to have lightning fast payments, because with traditional finance you have billions of transactions a day and millions of transactions a second, whereas Bitcoin and other cryptocurrencies like Ethereum, we've got to catch up. But I try and use Bitcoin anywhere where it's accepted. There's a lot of nonprofits. There's a lot of charities that accept Bitcoin. There's also Lolly, which is really cool, right? It's a Chrome browser extension that allows you to earn Bitcoin while you're shopping for things that you would every day. Not a lot of obviously more places take Bitcoin than Ethereum and then other cryptocurrencies. But amongst my friends in the space, we all send each other crypto and pay each other back and all that in crypto, mostly in Bitcoin. But I'm not I'm not a Bitcoin maximalist. I'm chain agnostic. It's just Bitcoin is the most efficient, I found.
Yeah, that's a huge piece that we like to bring to our hackathons. And also as Bitcoin Bay, we are blockchain agnostic. We want to we aim for an interoperable future, and an interoperable future, the rising tide raises all ships. So that's super important. And also each blockchain is built for a particular use case, and there's nearly infinity use cases out there. So it's comparing a lion to a shark in lots of cases, to borrow Andres Antonopoulos' analogy.
Exactly. And I find, to add to that quickly, I find that people who are, very maximalist in terms of one chain over the other, I think have sort of lost sight of the fact that blockchain and Bitcoin and all these cryptocurrencies, it's still very small. We're not scaled enough and large enough, and there's not enough adoption to start fighting between subsets, right? We all need to push forward to have more user-friendly products, have faster transaction confirmation times, and really develop the technology that powers the blockchains that we use. And so being a maximalist in one blockchain or coin to another, I don't think it helps the cause at all. And I don't think we're big enough to start saying, well, I'm a Bitcoin maximalist, or we're all kind of moving towards the same goal. And I think we should move towards that goal together rather than constantly fighting each other.
100%. Couldn't agree more with that. That's amazing. So there's a question here with a couple upvotes. So people want to know about this. I think you touched on it a little bit during your talk, but maybe you can go a little bit deeper. It says, would proof of stake exacerbate the status quo and have more barriers to entry? Basically, I guess, if you've been around the space long, you probably have more of the currency. Would that be prohibitive for new people trying to join the network?
That is definitely a factor, right? Because with proof of stake, it literally is the more coin you have staked, the more probability you have of being rewarded and being the validator chosen to forge a block, right? And so there is the argument that it does put up more barriers to entry. And as we can see, there already are staking pools, right? So for blockchains that have very high barriers to entry in terms of, the amount of, because you can have blockchains where there's a high amount of coins that need to be staked in order to participate. So you already are seeing staking pools. So there definitely is that factor to consider, that it does kind of, in one way, decentralize the network further, but in another way, it does add another entry to barrier. But there are, blockchains where there's a very small percentage that you need to stake in order to participate. But again, it's kind of still in the experimental phase, right? People are still playing around with it. We're still trying to perfect it and see what works, and what works for one chain, and its intended purpose is not going to work for another. So I think that definitely there's the possibility that it will add, further barriers to entry, and it will kind of occlude and prevent some people from joining if that's the intention. But I think there is also the possibility to further decentralize the way that we add blocks and the way that the blockchain works, if those barriers to entry are purposely kept low, and that's the way that the chain was designed.
Right. Yeah, we're still early days. We're still trying to figure this out, and I think a huge piece of why we want to go toward proof of stake is a bit of the energy consumption issue.
Mm-hmm.
So yeah, I mean, with there's no perfect system yet, but I think we're trying to solve issues as they arise. But yeah, it's another nut that we got to crack.
Yeah, and I mean, there's a lot of very intelligent people and very, passionate people working on it. So I trust that they hopefully have the intentions of the not, of the non-whales in mind. And there's, like I said, it's every blockchain can use a different proof of stake model. It's not like the Bitcoin blockchain where it's kind of like it's not going to change and you're not really going to add to it. The way that it works is the way it's always going to work. So there's a lot of room for improvement. There's a lot of room to learn. There's a lot of room to test. And again, a lot of people want absolutes, but we're still developing it. We don't have an answer because we're still creating the answers. We're building the answers as we speak. So we have yet to see how it's going to play out, because when ETH2 launches, whenever that is, if there's a hard fork to proof of stake, then we'll see.
Yeah. Okay, so we got two more questions here I want to try and get through. One is about what blockchains do you know of that are using proof of stake currently, and like how secure are those networks? So like how far are we along, I guess, validating that proof of stake is going to be a viable solution? Is there any use cases that we can look at today?
Yeah, so Anchor protocol is using proof of stake. A popular method is kind of the blended model, right? So that the coins are minted using the proof of work method, and then you add later the transactions are validated using the proof of stake. Then afterwards, people are rewarded using the proof of stake method. So there's blended models that are being used. But yeah, I would look to Anchor. They're doing a pretty cool job. Again, these are all really new. So it's not like, oh, this blockchain is doing it perfectly and they've got it figured out. But yeah, there's a lot of blended models that are being used. And Anchor is kind of the biggest one that I would point to.
Cool. Yeah, I've been like we were speaking about pools. I think Anchor is one of their products is Staker by Anchor, that is aiming to create pools so that folks that don't have, at least in the case for Ethereum, I know you need 32 Ethereum to create a staking node. If you don't have that much, you can pool together so that you can take part in staking in that way. So in more ways, it is allowing more inclusivity, because to be a miner today, at least in proof of work, you need industrial size like operations, which definitely is exclusionary. But at least with proof of stake and pooling, you can pitch together your little bit of cryptocurrency to contribute, right? So
yeah, because
go ahead.
I was just going to say, because with proof of work, there is a misconception of like, oh, I can just go, you can buy ant miners for relatively cheap. And then there's a misconception that, oh, I can just go and, you know, buy an ant miner and hook it up and there we go. You can, but it's really only profitable if you have millions of ant miners all running, at the same time. And so the staking pool, it's again another way to kind of piggyback off of that, and let people who don't have 32 ETH, which is still a significant amount of money, participate.
Right, that's awesome. Okay, so one more question about proof of stake here. It's revolving around sharding. Like, is proof of stake sharding, or what? How does sharding come into the play here? Oh, Kate has dropped off, and I don't know if she's going to be back in time. But I'm going to try and answer that. So, from my understanding, sharding is a scalability solution that is going to be implemented on specifically on Ethereum, but there are other projects that are using sharding, and it's about segregating, making essentially smaller blockchains that are connected with each other in the same network, so you can have more throughput, and they all get reconciled on a single thread on the main chain. So not necessarily directly connected with proof of stake, but Ethereum is going to it has on their roadmap to implement sharding in their roadmap towards moving towards proof of stake. Okay, last question here that I want to address is more of a hackathon related question, and somebody wants to know how many teams there are. Your guess is as good as mine, my friend, but there is a spreadsheet with people that are looking for teammates that I will share with you now in the chat. And so you can see how many teams are there right now. That's not to say that's all of the teams. There could be some teams that don't need team members that are working away in secret. And I know personally that there are a couple teams that have come in with projects before, and they're hacking away. So my suggestion is get to work. And if you're looking for a team, or if you're wanting to join a team, if you're looking for teammates, go to that link there, and you can find some folks there. Also, head over to the Discord chat. There's a team formation channel there that will get you all sorted out. Okay, I see Kate is back in the chat. It's all right, Kate. Don't worry about it. We're just coming up towards the end there, anyways. So I want to extend a great thanks to Kate for that great talk and those amazing answers to questions. Let's take a quick look at the poll here. Yep, proof of stake destroyed it with almost 78% of the vote. And a resounding 60% of folks are waiting to see if ETH2 ever comes out. They're sitting on the fence. But second place is folks are ready to stake. So either you're waiting or you're ready. So that's super cool there. So I want to thank everybody that tuned in live. I really appreciate it. And we're doing these every Monday, Wednesday, Friday, and Sunday. We got workshops coming up for you guys. So make sure that you're following us on our Crowdcast, and you can see a list of all of the upcoming events. This is our first time using the Crowdcast platform. So we're testing things out, and we're continuing to improve and get better. And so on that note, I'm going to drop a link in the chat here for a survey that you can go and you can rate us. How did we do on this workshop? And if you have any advice for us, we'd love to keep the conversation going, keep the improvements coming. And on that note, I appreciate everybody for being here. We look forward to seeing you guys in 2 days. On Friday, we have our keynote speech by Kelly Peters from BWorks. So look out for that. It's going to be super great. Behavioral economics is a very interesting topic, and I can't wait to see Kelly's talk on it. And there's actually a couple more talks. So check out our the portal, the schedule on there for all the talks from BWorks coming up. But in 2 days, Kelly Peters, BWorks keynote speech. And on that note, folks, Have a great evening, morning, good night. We're global, so I don't know where you are, what the daytime's like, where you're at, but we look forward to seeing you guys around on the next workshop or talk. Take care, guys.